All right, let's get started on Chapter 3, Section 2, or Section 2.3, Properties of Parallel Lines. So now we're locking the transversals. We're locking these guys into parallel. So no matter what, those guys are going to be parallel, and we're going to throw a transversal across them. So when you look at our hamburger analogy, the buns are now parallel, and the whole thing shebang is going to be cut by a transversal. All right, so I want you guys to write down the definition. Same side interior angles. If two parallel lines are cut by a transversal, so we got our little scenario, then the pairs of same side interior angles are supplementary. So I think of it, if you're in the meat and you're on the left, like 3 and 5, or if you're in the meat and you're on the right, like 4 and 6, then you are same side interior angles. So I'm going to add those angles here so that I have a list of them. So angles 3 and angle 5 are same side interior, and also angle 6 and angle 4. And when we add them together, they equal 180. That's what supplementary is. So if you're 5 or 5 and 3, you add up to equal 180. And if you're 6 and 4, you add up to equal 180. Okay. Let's look at alternate interior angles. If two parallel lines are cut by a transversal, that's this scenario here. Make sure you guys write that down. So we have two parallel lines, and they're cut by a transversal. They create these 8 angles, so go ahead and write down 1, 2, 3, 4, 5, 6, 7, 8. Then the pairs of alternate interior angles are congruent. That means they're equal, yo. Their measures are equal. So that means alternate interior means you're in the meat, and then you're one on the right and one on the left, or you're in the meat and one on the left and one on the right. So here's the meaty part. I'll color it in crayon for you because that's why not? It's fun. So here's our meat. So if you're in the meat and one of you is on the right, like 6, and one of you is on the left, like 3, then you are congruent. Or you can even say, if you're in the meat and one of you is on the left and the other of you is on the right, you are also congruent. So let's write those down. So angles 3 and angle 6 are alternate interior angles, and angles 4 and angles 5. And these guys are going to be congruent. And we're actually going to prove this. I can't wait. Okay, so let's prove it. So given A, and then you guys look at this little like bars right here. That means parallel. So if A is parallel to B, we are going to prove angle 2 is congruent to angle 3. So let me zoom this in for y'all. So it's just a little bit bigger. Oh, I think we can go even more. Let's make it happen. Make it giant. Oh yeah, so satisfying. Okay. So we are going to prove that line A, we're given line A is parallel to line B, and we're going to prove that angle 2 is congruent to angle 3. So 2 is right here, 3 is right here. Hi. Uh-oh. All right. Sorry, I was using the wrong diagram, the one from above. So I'm going to cover this one up so that we can keep our focus on the one we're trying to prove. Okay, so we have two parallel lines. Make sure you guys write this down in your notes. So we have two parallel lines, and they're cut by a transversal. And we have, we want to prove that angle 2 is congruent to angle 3. We're going to use 1. Don't let him be left out. We're going to use angle 1 to help us do that. All right, so when we declare the item that was given to us, the reason we're able to justify the declaration is, given. All right, measure of angle 1 plus the measure of angle 2. How dare we say that they're equal to 180? Well, what gives us the right? Oh, linear pairs are supplementary. So that means they add up to be 180. Alrighty, now measure of angle 3 plus the measure of angle 1 equals 180. What gives us the right to say that? Oh, this does, the same side interior angles postulate. It says that if we're on the same side and on the inside, so same side, they're on the right, and they're in the meat part, then they're supplementary. So boop, we say same side interior angles postulate. Now, just like we did in the past, we are going to, let me give you the reasonings and then we'll, so we're going to use the transitive property of equality to say angle, if the measure of angle 1 plus the measure of angle 2 is 180, measure of angle 1 plus the measure of angle 3 is 180, we can say, we can cut out the 180s, and we can say that the measure of angle 1 plus the measure of angle 2 has to equal measure of angle 1 plus the measure of angle 3. They're both equal to 180, they have to be equal to each other. Now we're going to do some subtraction. Look at what we're trying to prove. We're trying to get just 2 and 3. What do I have to subtract to just get down to 2 and 3? Oh, I got to subtract the measure of angle 1. So I'm actually going to write that down so that this is bonus material. So we're going to subtract the measure of angle 1 from both sides. He's the one we want gone. See ya, sucker. So now we have measure of angle 2 is equal to the measure of angle 3 by the subtraction property of equality. Now, definition of congruence. If the measures of two angles are equal, we can say that the angles are congruent. Angle 2 is congruent to angle 3. What? That's what we're trying to prove. And so that's the definition of congruence. All right, let's take a look at another one. The corresponding angles theorem. Okay, so if two parallel lines, so let's make sure we write this down so we don't lose it. Corresponding angles. If two parallel lines are cut by a transversal, then corresponding angles are congruent. That means their measures are equal to each other. So go ahead and draw this. We have our parallel lines, and we have our transversal, and then we have 1, 2, 3, and 6 as our angles of focus. So we are given that these two lines are parallel, and just for fun, let me show you. We use this little arrow on each line as shorthand for parallel. So if you see the little arrow, that means parallel. So these two lines are parallel. We're going to prove that angle 6 is congruent to angle 2. Okie dokie. And we're going to use 1 and 3 to help us out. All right, so we're going to take our given and write it in number 1 as our statement. Oh, and the reason is going to be because we were given it. Okay. Next item, we're going to say angle 1 and angle 2 and angle 3 add up to equal 180. So if you look, oh yeah, they are just like before. Angle 2 and 3, they make a straight line. Oh, if they make a straight line, then they're equal to 180. Let's see if I can get it. So what's that called? Oh, that's the same as before. It is called the linear pairs are supplementary. Okay, we did that before. We're getting it. We're kind of familiar. Now we're going to say that the measure of angle 3 plus the measure of angle 6 is equal to 180. This is, so look at this, it's in the meat section of the picture. They're on the same side, so they're same side interior angles. Postulate says that if they're on the same side and they're on the interior, they add up to equal 180. Woot, woot. Okay, now let me give you the reasonings for the rest. Transitive property. So we're going to look at these guys here. We're going to do something similar to the problem before, where we say if these two add up to 180, these two add up to 180, then they are equal to each other. So if they're both equal to 180, then they have to be equal to each other. Now we're going to use subtraction property. We're going to subtract out that angle 3 because we only want 2 and 6. All right, so I will go ahead and sneak that in there. We're minusing out measure of angle 3. So we use subtraction property to get that the measure of angle 2 is equal to the measure of angle 6. What? And we're trying to prove angle 2 is congruent to angle 6. Definition of congruence is that if the measures are equal to each other, then the angles are congruent. Da, 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 da. Victory. All righty. Next item, we are going to do alternate exterior angles. So we're going to focus on 1, 5, 8, and whoopsies, I got rid of them on accident. 7. To prove the alternate interior exterior angles. Guys, don't record videos late in the evening. It gets all crazy. Okay, so the conditional statement says if 2 parallel lines are cut by a transversal, we should be used to that statement by now. Then the pairs of alternate exterior angles are congruent. Alternate exterior angles congruent. So that means the angles that are in the bun region of the hamburger, and one on the left, one on the right. So like 1 and 7. All right, so you guys, I want you to draw the picture. 2 lines parallel. They're cut by a transversal. I know, I'm so good at drawing straight lines. I'm amazing. Okay, so we are given that A is parallel to B. We want to prove angle 1 is congruent to angle 7. Let's see what kind of shenanigans we're going to do. Step number 1, throw down your given. Even if you don't know what to do, go to step 1. Okay. Step number 2, angle 1 is congruent to angle 5. 1 is congruent to 5. Ooh, let's see, what gives us the right to make that statement? Oh, it's the one we just did. Corresponding angles are congruent. If you're in the same position, so if you're both on the left-hand side and both above the non-transversal, your corresponding angles, and you are congruent. Da, 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 da. Angle 5 is congruent to angle 7. Oh, I know this one. He is an old friend of ours. He is vertical angles across from each other. I remember you, bud. Okay. So we just want 1 and 7. We have 1 and 5, 5 and 7. How do we get rid of the middleman? What's that called when we want to get rid of that middleman and say angle 1 is congruent to angle 7? Oh, that's right. It's a transitive property. Boop, boop, boop. We did it. Good job, guys. All right. Transitive property. Okay, we're going to take a look at some examples, and we're going to see how if you're given one of the angles in our 1 through 8 scenario, you can find all the rest of the angles. Okay, so we're given measure of angle 5 is equal to 65. We're going to find each measure and tell what postulate or theorem you used. Okay, measure of angle 5, which is right here, 65. Write that down. Oh, I know how to get 6. He is also 65. Boop. Because he is a vertical angle. Okay. Okay. Measure of angle 7. So measure of angle 7, he is flanked by 2 65s. Well, we know that a straight line is equal to 180. So if I subtract 65 from 180, I will get angle 7. What is that called when you add up to equal 180? Oh, that is called a linear pair. Okay. Alrighty, so I'll write that down for you. So he is 115. Okay, angle 8. Ooh, angle 8. 65 degrees. Let's go. We can either use alternate exteriors or corresponding. Let's use corresponding because we haven't already. So angle 8 is 65 degrees because he is congruent to angle 5 by corresponding angles. They're in the same they are in on the right hand side of the transversal, and they're both above their crossing lines. If you, I will go back after I do number 9, and we'll I'll show you where the hamburger and stuff is here. Measure of angle 9. Well, we could do that. We could say he adds up to 8 to equal 180, and we've already done that. He's 115. We can do, let's use alternate exterior angles are congruent because we haven't used that one yet. So he is an alternate exterior angle. There's 2. Okay. And then I threw in this last angle because why not? Oh, he's 65. Just for fun. Okay, so let me show you the hamburger here. I'll do some crayon drawing because, you know, I love it. Okay, so here is the meat. He's kind of the meat is in between the parallel lines. Okay, so your hamburger is kind of laying on its side. It's a little bit different. I'll clean that up. Don't you worry. There we go. Cleaning up our hamburger mess. Okay, and then the bun is here. So my hamburger is kind of chilling on its side. It doesn't change anything at all. We just have to tilt our heads to the right a little bit. Okay, if you know, this is it. This is the last one. What? So that's our secret phrase, you guys, for this session is sideways. We'll make it sideways. Okay, if you know all the measures of one of the angles, you can always find the measure of all 8 angles when two parallel lines are cut by a transversal? Yes. Can you always find the measure of all 8 angles when two parallel lines are cut by a transversal? The answer is yes, and it says explain. It's either going to be supplementary or congruent to the given angle. So whatever angle you're given, the other angles are either going to be supplementary or congruent to your given angle. So all you need is one angle, and I'm holding up my finger in little number 1, my little pointer finger. It's always going to be, you only need one angle to get all the other angles. All right, that is our lesson for today. Thank you so much.